everybody, to the VanderSpa. This is the second VanderSpa webinar series, and we're glad to have you with us. Sorry for the short delay as we get some technical things worked out. We're trying to make this experience better for you as well for us. If you can hear me all right, just say something in the comments that we are live. Looks like yes. Thank you so much, Jeff. Mr. Bean, good to see you there. Cheryl, hi everybody. Brian, so glad to have everybody on board. Isn't it great to be in writing season? Just by the show of hands, show me how many of you have had your Vanderhalls out so far. Look at that. Thank you, Ron. Michael Sayer, glad to see you. Shonda, excellent. Nathan, look at those thumbs up. Welcome, everybody. All right, we're going to get this thing rolling. We've got some amazing content for you today. I just crawled out from underneath the Vanderhall about an hour ago myself, working on a customer's radius rods. So we're going to be touching on radius rods. And we're also going to be, what else are we talking about, Troy? Gassing your vehicle, batteries.
Gassing vehicles, battery changes, all of the stuff that people are starting to experience here at the beginning of the season.
Please mute that mic.
Where you're realizing, oh my goodness, my battery's dead, or whatever the case may be. You're pushing the start button, nothing's happening. There's a lot of things that could be. We talked about a lot of this last month. We're going to try to be a little more high level with this particular webinar so that we don't lose people in the weeds. But radius rods is kind of the first topic of discussion. And I hold in my hand a radius rod. This is part of your front suspension if you have a 20 or newer machine. This is going to be all Carmels and 2020 and newer Venice that utilize a radius rod. On the fly here, I'm going to ask my production team here to see if they can find the graphic to put on this television here of the lower control arm assembly that includes this radius rod. It's a picture we took off the Vanderhall website, and I think it'll be easy. We're still working on pictures, so we'll get to that in a minute. Anyway, radius rods. And this guy's going to be so tight I can't get it apart. But a radius rod appears. The trailing end is connected on the control arm right here. This part is connected to the chassis. The chassis actually sits between these two polyurethane bushings. And the job of the radius rod, when it's connected to the lower control arm that's connected to your chassis, is to keep the lower control arm from flexing backwards or forwards when you are braking or accelerating. And it's called a radius rod because this arm right here travels on a radius up and down as your lower control arm is moving up and down as the chassis is raising and lowering in relation to the ground as you go over bumps in the road. So this has to be able to rotate and it has to be able to articulate up and down in order to do its job while keeping that lower control arm where it belongs. I'm going to draw this from above real quick. See if we can't make this look about the way it should. Bushing, bushing, washer, washer, bolts. This is chassis wall. Here is your chin going forward. Side of the machine comes back like this. You have lower control arm coming off this way with a ball joint in the bottom. There's a plate right here, comes out this way, has a hole in it, and your radius rod comes back, connects to that hole, comes back up
All right, folks, can anyone hear me? Looks like we've lost some of our tech. Okay, so I am live. Okay, thank you. Troy, let's see if they can hear you.
This is
Good.
Nobody can hear me right now?
Nobody can hear either of you through those microphones.
So it looks like I'm just unmuted and they can hear me through my
Yeah.
laptop.
You're the only one.
All right. Well, so much for our royal efforts, our efforts to make this even better.
Well,
It tumbled.
no.
All right. Well, you guys get to see the sausage being pushed through the machine backwards. Stand by. We'll see if we can get it back up and running.
I don't know why I owned this truck. That was absolutely a power thing because all my screens work.
Okay, so I'm going to ad lib and talk about radius rods for just a second because I just took one of these apart. And Troy, you'll be listening in. You can actually come over and dodge on this screen and we'll tag team it here.
Okay.
So I'm Steve. I work with Troy for the last year. Together we've probably done 100 cars with radius rods. Is this working out? Oh, someone says they can hear Troy. All right, very good.
Okay, you can hear me. You can hear me through the laptop, or you can.
I think we're going through the laptop. I
Okay,
think.
yeah, just the laptop mic. All right.
Zoom isn't even on this computer right now. So
Okay, that's what they're saying, laptop. Thank you for the feedback. Okay, so radius rods, one of the things that you can check when you're driving, let's just talk about the what an owner can do to check the condition of their radius rods.
Okay.
And I remember when I hopped in a Vanderhall for the first time, I noticed that, I love the outrigger wheels, and those turn out to be really good indicators of whether or not your radius rods are loose. So if you ever feel like your front end is being a little bit loose or wobbly, there's a couple things you can check. And when you hit the brakes, even gently, and you see those fenders roll forward a little bit, you can bet that your radius rods are loose. Troy, do you want to share what you've learned about other indications of loose radius rods?
Well, the primary indication, if you are a driver who is sensitive to the direction of your vehicle, is especially at highway speeds, at higher speeds where it's easier to put more force into the front suspension by putting on the brakes. If your radius rod is loose on one side, it's going to allow the lower control arm to shift backwards, and that's going to change the trajectory of the wheel. So when you apply brakes firmly, let's say 60, 50 miles an hour, trying to haul it down to say 30 miles an hour, if you can sense that you're having to rotate the steering wheel a little bit in order to keep the trajectory of the vehicle where it belongs, there's a good chance that you've got some dynamic alignment stuff going on in the front end because of things that are loose.
And you've seen the fenders come forward before? Is that
Yeah,
appropriate way to check?
And what I recommend for anybody that's got the all black suspension components, if all your suspension components are black, you have a radius rod style of front suspension. When it's time to get gas, when you're crawling into the gas pump, if you will, you're only going 1 or 2 miles an hour. If you'll just pulse on the brakes like you're just inching up on the pump, just cyclically on and off the brakes, on and off the brakes, on and off the brakes. Look at the fenders on your machine, specifically focus in on the trim screws that go down the center line of the fender. And if you detect that that trim screw is jumping up, like it wants to go over the top of the tire, if it's jumping more than, say, a 1/4 inch, there's a high likelihood that the radius rod bolt on that side of the vehicle is loose. Now, this on vehicles from 2020 up through late 22, I would say those are the vehicles where we're really concerned about things getting loose. And the reason for it getting loose, Steve, do you think that they can still see me even though we can't see me? Or have we lost our ability to?
Yep, we're getting a thumbs up that.
Okay, everybody can still see us.
Yep.
Good. Okay. So
Thanks for the feedback.
Here's my theory. Okay, I don't have proof of this, but I think we've had enough evidence to be able to make a pretty good guess of what went down. I have a feeling that the lower control arm assembly, which includes the radius rod system, was probably pre-built by a subcontractor to Vanderhall. And I can envision Vanderhall asking that entity, would you please grease the bushings on the radius rod ahead of time so that when our assembly workers take the lower control arm systems out of the box to put them on the side of the vehicle, they don't have to be trying to paint and slather that sticky grease onto the bushings, because these kind of bushings will absolutely squeak and drive you nuts if they're not properly lubricated. But somewhere in the process of assembly of this setup here, they went ahead and put the bolt through the bushings and the washers. And in doing so, the bolt threads got contaminated with that same grease. So now for maybe about an inch of the end of your radius rod, this is the lead end, the part that connects to the chassis right behind where the chin overlaps. The lead end of that has a male-female thread system where there is grease present. And I'm going to relocate myself back over to the main camera as soon as I'm told that we're good to do that. Am I still?
Yep, you're good
Is
to
that
go.
going over there?
Yeah.
Okay. All right. So we're back. Now everybody can see this illustration, I'm guessing. Do we have this illustration close enough to the camera for everybody to see it well enough, or can we zoom or move the?
And we cut back over to our main microphones. Can people still hear Troy and I well?
Okay, my mic is green.
Okay, we're getting
we
good.
good?
Thank you, Terry.
And we're back.
Thank you,
All right.
Ron.
Thanks for putting up with our reboot
you guys are
process.
such good tech support people. You're helping us help ourselves. Appreciate
That's awesome.
that.
Thank you for the feedback. Okay, so the vehicles that are subject to this loosening behavior are typically going to be all Carmel up to late 22 and all Venice up to late 22. If you, as an owner of those vehicles, never received an email from Vanderhall educating you about a technical service bulletin that they came out with to address the very thing that we're talking about right now, they just didn't have your email address on file as an owner of a 20 to 22 model vehicle. We don't have the details on that TSB here, or we can present them on the screen. It's not hard to find. I think it's posted as a sticky under the Files tab of the Vanderhall Performance and Accessories page of Facebook, if you have access to that particular group. Anyway, so what happens exactly? I'm going to refer to this illustration that I've drawn here, and it's almost to scale with this rod here, but the rod sits just like this.
Put a little tread on your tire so they can tell the difference between that and the chassis.
Tread on the tire. Let me get my pin.
So this is a top-down view.
Yeah, we're looking from the sky.
And this would be the passenger side with your tire being on the right. There you go.
Right.
I thought you would do like the good General Flames.
Yeah, well, I don't have time to be an artist right now. I already feel the pressure. So several things happen when you put the brakes on. Okay, the first thing that happens is, because of the mass and the weight of the vehicle, the tires want to stick to the ground and slow the vehicle down, but the chassis wants to keep going. And that sets up a situation where this radius rod gets pulled on because this lower control arm wants to shift backwards when you put the brakes on. And another thing happens when you put the brakes on, and that's weight transfer. So your bodies, the weight of the vehicle, it all pitches forward when you put on the brakes. So what does that do? It causes the suspension to flex like this as the weight of the vehicle in the front causes the nose to dive. You've probably seen that before. You see somebody coming up on a school zone, they throw their brakes on and their nose dives. All right, well, let's go through the motions here. We put the brakes on that drew tension in the radius rod, and then the nose dived, and that caused the rod to rotate counterclockwise because it's connected to your lower control arm that's swinging up when the nose dives. So we're drawing tension in the bolt unscrewing the rod, letting off the brakes, the bolt head pushes back up into the chassis, and then it follows the radius rod back the other direction. So what that means is incrementally, brake cycle by brake cycle, when you put the brakes on, tension, counterclockwise rotation, release, comes back. Millimeter by millimeter, brake cycle by brake cycle, the rod is unscrewing itself from the bolt. So why is that a big deal other than the fact that, you know, your car's coming apart? So this is where I'll refer back to my illustration that I keep getting in the way of. The next key factor here is steering. You're holding the steering wheel straight. You're expecting the car to go straight. Let me back up and say this. If this radius rod wasn't connected, there is enough width here with a through bolt going through the lower control arm that it pretty much wants to hold the lower control arm straight out the side of the vehicle. However, when you brake softly, you're not deflecting the angle of this control arm very much. But when you put the brakes on hard, it really wants to bend backwards. And if this rod and this bolt aren't coupled together and tight so that there's no gap in here, then what actually happens is this backs up.
This has been.
Okay, we're back. Let's see. Can you hear us now?
Technology.
We got one machine working. Okay.
Just remove.
All right, we're going with the single computer solution. So
Okay.
here we go.
All right. Wonder if
Okay.
rotate you, face your camera towards the
All right.
poster, and maybe I can keep kind of talking about this. Let's rotate this just a little bit that way.
Build the solution real quick.
There it is. Boom. Now we can still see our board here.
It's doing the autofocus. So go ahead and
Auto zooming on
Yep,
me.
yep, go ahead.
Okay. I think I can work from here now. Okay, good.
Don't look, just
Good,
talk.
good times. So the next piece of the puzzle is you got a tie rod here that connects to your steering wheel. This is what moves the back of the wheel left and right and allows you to steer. When the lower control arm is able to shift backwards, I'm going to pretend like this is my control arm for a second, or my tie rod, excuse me. When the tie rod pushes back, it also pushes outboard. It's getting longer in that direction, which is pushing the back half of the wheel this way, which means if you're loose up here and there's a dog in the road and you throw the brakes on, this wheel is going to turn inboard enough to redirect the vehicle. And if you're not expecting it, and you're on a 2-lane undivided road with oncoming traffic, and you're going 45, 55, 65 miles an hour, this wheel is going to invite the car to go to the left. Now, the challenge here is that's the more risky proposition, and it's also the more likely proposition because the bolt in the end of the radius rod is right-hand thread. And like I just got through explaining, when we put the brakes on, the nose dives, the rod rotates, and this bolt is greasy. It's disassembling this connection point. On the other side of the car, when you put the brakes on, I'm going to move it here so you can see the rotation. On the other side, when you put the brakes on and the nose dives, it's rotating clockwise. So it's inviting the opposite side of the car to stay tight. And so if we're tight on the left, but we're loose on the right, when we brake and the radius rod bolt pays out excess length, because the control arm wants to be here normally, it has to be under stress to flex back. So if you're just coasting, it's pretty much perpendicular to the chassis, but you put the brakes on and it wants to flex backwards. That's going to redirect the car.
Okay, so can I summarize a little bit with the props?
You bet.
So when I take these apart, I'm actually looking for the spacing on the passenger side car. And that's where all the failures are. I think we've seen more broken bolts on the right-hand side than the other for that same reason. What happens is this assembly gets loose a little bit, and then it starts to hammer on itself. And hammer and twist equals high stress on the threads of the bolts. And when it breaks, you actually can't see it. You typically don't see it because it breaks right inside of this washer right at the end of the bar. But the end of the bar is usually jammed up against the frame. And so one quick thing you can do is look and see if you have this washer. If you can see that shiny washer, if that washer is missing, guaranteed your bolt has broken. So I've seen a couple of cars come in without that washer there. So as a pre-drive check, just stick your head under. You can use a little bit of flashlight. You kind of have to look forward between the chin and the body, and you can see that. One of the things that you'll also want to look for is space. If I need to get a piece of paper, something like this. A card, if you can stick there we go. If you can stick a credit card in between that, you don't want to be able to stick more than 2 credit cards in there at any one time. One is fine at the top because at rest, this thing's actually flexing this way and it'll open that top gap up. You can also check the condition of this bushing. There will be a lot of times where this will be sunk in. Typically, you want it to sunk in about half the width of the bushing, so maybe a 1/16 of an inch.
Width of the washer.
Sorry, half the width of the washer. And other times you may see this actually mushroom and peel and blister and sometimes just fracture. That is a very high indication that is an indication that your radius rods are either too tight and they're too old and they need to be replaced. Sometimes you'll see the bulge on the bottom, and that is an indicator that your particular chassis had some weld sprue on the receiver for this bushing, and that will need to be cleaned out the next time you get in there with a Dremel tool or something like that as you put new bushings in. What else can they see
Let me
as they look at it?
let me just go back and help understanding here. So there's 2 different concerns for a radius rod equipped vehicle Vanderhall owner, depending on what year your vehicle is.
We can try switching back now. I lowered quality and
We
everything.
can try switching back. Okay, we're taking our resolution down to see if we can maintain stability. So we're going to try switching back over to our other rig here.
Dropping 30 FPS if it'll stay alive.
Just thinking maybe we're bandwidth limited here, which we didn't think we were.
I'm
Just
Just
go ahead
do
and
it.
cut
Let's
over.
just go.
please put me in trouble.
Yeah.
What do you like?
Okay.
Yeah, recording.
Everybody can hear me in the meantime, though, so I'm gonna keep
Yep.
talking about this situation. So we started working on enough of these units
Just use this one.
that we saw.
All right, we're back
We're
to
back. Okay, thanks, everybody. So we saw this issue repeatedly. If I can have the floor, gentlemen, that'd be great. Thank you. We saw this issue repeatedly and we figured out that the bolts were greasy and stuff's coming apart. So we notified. What's up?
lift it up so you can see.
Sorry.
There you go.
Okay, yeah. So we notified Vanderhall and we said, guys, we're seeing this over and over again, that this bolt is backing itself out. And we feel like it's a concern because the operator may put the brakes on unknowingly with it being really loose, and they may experience a directional change. that they're not expecting. So they did some research. They purposefully maladjusted one of their vehicles. They went in and loosened one of them a lot on one side and then took it out on a test track. And in doing so, we suppose that they found the same precarious situation that we considered it to be. And 3 months later, those of you that they had email addresses for got a TSB by email, and all of the dealers got TSB notification for a particular range of VIN numbers. Again, this is data that we can push to you guys as thank you for coming to our webinar. We can send you the data of what the VIN number range was. But in the meantime, we got to fix the problem, right? So how do we fix the problem was kind of the next question. Vanderhall came out with a TSB, Technical Service Bulletin, that addresses this their way. Their way is take the nose of the car apart from the rest of the chassis so you can get to this bolt because it's placed right behind the sway bar. I was going to go back up. Can you move the camera so it can see the dry erase board?
Sure.
Perfect. So there's a seam in the chassis. This is almost not to scale. The nose doesn't come back quite, chin doesn't come back, sheet metal doesn't come back quite that far. But there's a seam like this. Your sway bar bracket, the sway bar comes through here up this way. I hadn't even drawn it. Don't confuse your sway bar with your radius rod. The radius rod is the closest rod to the ground. But the sway bar goes all the way through the nose of the chassis. And there's a bracket in there that supports the sway bar. And it's just absolutely in the way of being able to access this bolt when the car's put together. So you have to separate the nose section of the machine from the rest of the chassis. We split it open just like this, so you can get in from the bottom.
By the way, as we mentioned this, there is a ton of detail that we put in a 37-page, that's it, 37
I
page?
don't know how many
Yeah,
pages
it's
it has.
a 30-page how to service your radius rods. That comes free with any service, any radius rod kit that we sell. But if you want to just look at it to understand how to actually perform that service, we do that, make that document available on our website for $37. So you can just get that. You've got all the pictures that you could want, and you can
Torque specifications, the tools you need to do it. The whole procedure is outlined so that you can perform what we're kind of discussing needs to be redone here. Anyway, so I'm trying to make my story quick, but it's also relevant and important for those of you that have 23 and 24 models. And that is, Vanderhall had a lot of machines on their campus at the time that we notified them about the greasy bolt problem. And they had all been assembled with this same greasy bolt problem, but they hadn't left the mothership yet. So it appears to us that they factory corrected this problem with their own procedure. And their procedure was take it apart, pull the bolt out, degrease it, squirt a little degreaser up in the open end of the rod, let it dry, and then load the bolt thread up with glue, red thread lock, and then put it back through the bushing system and screw it back down into the rod. Where the problem lies for 23 and 24 model people is when they put this bolt back in, there we go. When they put this bolt back in, they put it in at a new torque specification that they came up with. I don't know from where. 45 foot-pounds is how they're asking people to put this bolt back in. That's probably twice as much as it ought to be. And what happens when the bolt gets put in too tight is now the rubberiness of these bushings is getting squished out of them like pancakes. Right now, on one that hasn't been over tightened, the rod has the ability to flex up and down, and the bushings are loose enough and pliable enough that they'll allow that. But once these two washers are squeezing together with 45 foot-pounds of torque, the bushings don't have any more flex to give. Now, when the rod gets pushed up under compression or drops down under extension, it's literally bending the tip of the bolt that is screwed into the end of the rod. And just like a coat hanger that we can flex back and forth, back and forth, back and forth, back and forth until it breaks, the bolts are breaking on 23 and 24 model machines. We've had 5 break notifications in the last week. And I think those of you that got new machines just this last year, or new to you machines that are 23 or 24 models, the sun's out, the snow's melting, and you're starting to be able to drive your machine for real, and the bolts are breaking. So be knowledgeable, be mindful that that risk exists until such time as you can get this taken apart and put together with new hardware, because the bolt that's in your radius rod needs to be considered tainted. It needs to be considered compromised, and it needs to be replaced.
So got a couple questions on this.
Okay.
Dutch asks, does this also hold true for hard acceleration? I think we were talking about at the time.
Okay, that's a good question.
What does it sound like, look like, feel like in over tight circumstance, or maybe even a broken bolt? Can we tell?
Okay, yeah.
Will you feel or hear anything about that?
Okay, so if it's loose, you're not going to feel anything, because using this illustration here, when we want to accelerate, the wheel is trying to take off without the car. So it's compressing the radius rod into the mounting position. So it's just butting up against the chassis at the length it's supposed to have. So you're not going to get torque steer or whatever, because torque steer would happen if the wheel was able to go ahead of where it belongs, or outboard towing out under something happening, not towing in. But if you have a broken bolt and you're accelerating and you're just coasting down the road and you have a little gap in there, and then you hit the gas, the rod's going to move forward because the lower control arm's going to crawl forward because the wheel's trying to take off without the car, and it will create some noise banging into, if it's still in the vicinity of that cup that holds these bushings to the side of the chassis, it'll be dancing around on there as you accelerate.
If you ever hear any tingle, 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 that something has fallen off, that is a really good time to actually stop and try and figure out what that was, and look for that wash.
That's a good point. These cup washers are very hard and they're made of steel, and when they hit the ground, they're going to ring. You will hear a metallic ting when it goes bouncing down the pavement.
It may chatter underneath the chassis and sound like you hit a spring, because it'll bounce up and get between the ground and the chassis.
Correct. So the challenge with this at this point is there are people that have 23 and 24 model machines that came from the factory through wholesale auction houses to the dealer, the motorcycle dealer that you bought it from. You bought it used, no warranty, and it has less than 20 miles on it. Super good chance that you've got over tight bolts and a break risk is in your future. Now, how can you tell that you are over tight? So right now, I'm going to hold this closer up to the camera. Right now, you can see that we can see the full edge of the washer independent of the bushing. Of course, this has only been put together hand tight for the purposes of packing. But this washer, if this bolt gets tightened to 45 foot-pounds, if you think about taking a quarter, heating it up with a torch, and then setting it on top of a jumbo marshmallow, it's just going to sink down into that marshmallow. These washers will press up into these polyurethane bushings where you can't see the edge of the washer anymore. So if you do a visual inspection of your radius rods on a 23 or 24 and the outboard washer edge is not fully visible, there's a really good chance that you have a 45 foot-pound torque bolt in there overstressing the bushings and looking for breakage.
Okay, so let me grab a couple more of these questions. Why not use left-handed threads? That's a great idea, and that would be fantastic as an aftermarket if we could get radius rods that were threaded, but from a mass production standpoint, they're all right-handed threads. So you'd have to get a left-handed bolt, left-handed radius rod, but that could address it.
The radius rod would have to be remanufactured.
Yeah, remanufactured. Another question was thoughts on the Togue factory solid mounted radius rod arms and joints as a solution.
Okay.
Is there a perceived loss of ride quality?
I will address that, but let me just mention a few other things that I think are important about this, and then we'll shift to that. The bolt is steel. The rod and the threads in the rod are aluminum. So if you've been driving a 20 to 22 model machine for some time and you learn that it's been loose, you could have back and forth, back and forth, back and forth of the steel bolt within the aluminum threads, and the aluminum threads will be worn down some if they weren't cross-threaded. And that's why our procedure for servicing this takes the radius rod off the car so that you can actually shine light down in the open end of it and see, is my thread system still healthy? Because if it's not, you would need to get another radius rod. This is where the Toge factory product comes in as a potential solution. So radius rods are currently on back order from Vanderhall through the end of April, I believe, is the ETA for them. So we don't have them right now. We can't get them.
We have a few in stock.
We have a few in stock, but we're hanging on to them for vehicles that come to us with broken bolts,
Yep.
because otherwise we're not able to help people. So the Toge factory rod, some people have seen it. I don't have an illustration of it. I could draw it, but I'm feeling kind of pressed for time here. So I'll just explain it in relation to this solution. Their rod is very similar in shape up to this point. The difference is they don't mount bushings on either side of the chassis here. They have an aluminum hockey puck on the inboard side, an aluminum hockey puck on the outboard side, but that aluminum hockey puck on the outboard side holds it holds a large heim joint, a spherical joint, so that when the radius rod needs to go up and down, it's not actually flexing anything at the chassis. It's flexing out here where my fingers are. So that changes by a couple of inches the effective radius of the radius rod, which from Vanderhall engineering standpoint is intended to pivot where my fingers are. When you put a TF rod on, now it's pivoting a couple of inches shorter. We purchased a kit for our own evaluation, and we had difficulty getting it to fit on the chassis that we worked on. Now, not all the chassis we worked on are built the same. Vanderhall never expected somebody to use a different type of coupling mechanism for a radius rod. So the inner welded ring and the outer welded ring that contain these bushings are not necessarily concentric. They could be shifted off from each other, where when you try to put a machined aluminum zero tolerance go or no go mechanism through the hole in the chassis, if the thread system is not going to line up, you're not going to be able to get it tightened up. And that's what we ran into with the two chassis that we tried them on ourselves. So we have installed Toge factory rod solutions on one customer car. We were able to do it, but we had to do cutting and grinding on the chassis in order to get a safe and appropriate fitment of that part. So I don't know how much of a DIY solution I would categorize it as. I would almost say if you want to go that route, you need to hire a professional to do the installation for you, because they may need to make some modifications to the chassis. And I would be concerned that those modifications be made with good judgment, so that you're positive you're going to be in good shape when that installation is complete. There's a little bit of a bump steer concern. Where are we now? Are we
Just keep
still
going.
on?
Keep talking.
Okay. There's a little bit of a bump steer concern in my mind. It's untested, because again, we just sent the setback that we bought because we couldn't get it to work on the two cars we tried. But if the radius rod is shorter than the factory radius rod, effectively, as it bends to ultimate compression and ultimate extension, it's actually inviting the lower control arm to pull forward, because the radius of the rod is shorter. And that would induce just the opposite of a loose bolt. Just the opposite of a loose bolt situation, it would induce toe out under compression or suspension extension.
You
Okay.
are live back on the main. Will you turn off your camera
Now
here
we have
too?
an echo, so we need to turn the volume down.
Ooh, that was turn your volume down.
Okay, so I'm here now?
Yep.
Okay, very good.
So we've got a couple more questions.
Okay.
Handle those.
Yeah, I just have one more point to make about the Toge factory solution, and then we'll go to those questions. When the factory radius rod is appropriately tied at the side of the chassis, it is resisting raising and lowering, which is adding to the anti-roll properties of the vehicle. So when you go into a turn, the radius rod is effectively increasing the diameter of your sway bar, if you want to look at it that way. So the car is staying flatter through the turns when you have a healthy, properly attached radius rod on the side of the chassis. With the Toge factory solution, they're removing 100% any assistance that the radius rod was offering in anti-roll properties. So I would just be mindful of that when you're doing spirited cornering and try to ask yourself, do I have more body roll now than I had before with my factory radius rods? Because the tension arm that this represents has been removed completely by a hind joint that presents no resistance. Okay, what's our other questions?
Okay, so we've got a couple of questions here. I think I'll answer some just to save your vocal cords for a
Get
sec.
some water.
So let's see. Rick, you bring up a great point that it is important to get the alignment after this service. Anytime you're touching the radius rod, you can see why that would be important to do. You can do the alignment is rather easy to do, and getting it aligned so that you can avoid any toe in or toe out is going to be a great benefit to you. Dow, let's see, you did the fix on your 21 Carmel before the TSB and you got the bolts out, degreased them and put them back in with thread lock. Should I still replace with the kit? If you haven't changed your sway bar end links, you may want to see what the condition of those are. That comes in our kit. We also include higher grade bolts that will be a little bit tougher in this application.
And they're also 5 millimeters longer, so they go further up into the radius.
That's probably the best thing to do is get those extra longer bolts so that you're actually having more thread engagement. So you may consider that. It is a lot of work to do, but we're still trying to figure out how long between replacement that is. Do we have an estimate right now between service of radius rods?
Well, that's a good point. Is what would be the ongoing maintenance for a radius rod system? These polyurethane bushings, for the engineers out there that understand polyurethane hardness scale, they actually refer to it as durometer. The durometer of the bushings that are put on the machine from Vanderhall is quite high. It's in the low 90s. It's very hard rubber. The durometer of the bushings that we're including in our kits is in the low 60s. So they have more compliance against, or they will allow more flexion than the factory bushings do. The other thing that's true about all rubbers and all polyurethane is the stuff just ages. It oxidizes, it dries out, it loses elasticity, and it is going to be an item that needs to be serviced at some point in the future because they will start to fail. We are seeing 21 model machines now that have crumbling and literally falling out in chunks radius rod bushings because they are at the end of their service life. So when the Vanderhall TSB calls for red thread lock in conjunction with using all the same parts all over again, you're starting with bushings of an unknown age that have on a 23 or 24 model been over compressed, and they will probably have a shorter life expectancy than a bushing that we know was just made.
So there's a great question right here from Arby that asks, would my thread lock system still, or my thread system still be healthy if I have a 45 foot-pound
bolt in there with 5,000 miles on it.
Right. So mileage, as long as the bolt hasn't been moving, I don't think mileage is a factor. But when we were taking apart greasy radius rod bolt systems to clean them up and put them back together, we would reject 10% of the radius rods that we came across because the thread system was already too worn down from the steel bolt rocking back and forth in the aluminum threads. And when we would take it out, we would often find just coils of aluminum thread material. That means that the pitch of the threads has been compromised a little bit, and we just don't feel good about putting it back together like that. So we would put a new rod on in those situations. Now, red thread lock adds another problem because red is high strength, removable with heat. That means the expectation is you're going to heat the head of the bolt or you're going to heat the rod itself with either a heat gun or a torch in order to melt the plastic, the hardened plastic red thread lock compound that has those things glued into each other. And if you start trying to get that bolt out before that's completely melted, it may just try to pull threads out with it when you back it out. So red is not the compound that we recommend. When you do the procedure according to our recommendations, we're using orange. Orange is a proprietary color of Permatex, and it's intended to be high strength, similar to red, but it's also removable with hand tools and without heat. And this isn't under so much rotational force that it's going to overcome properly applied orange thread lock.
Excellent. That was actually a question. So Dutch, you got the answer right there. So orange is what we use instead of the red. Let's see. Recommended torque, 20 to 22 foot-pounds is what we're recommending. Then we've got Terry Sapko, the let's see. Do we place the rod? Do we replace the rods and the bolts, or just inspect and adjust for an over-tight bolt? Just curious what we have.
Okay.
So maybe if you could describe what we do in our service,
Right.
what we replace,
Right.
what we inspect.
So, and I want to compare and contrast with Vanderhall's recommendations as well, just so you understand how much more thorough we're trying to be. They leave the radius rod connected to the lower control arm. So it's difficult for you to swing this thing out, shine light into it, inspect and adjust the threads, inspect and degrease the thread system and evaluate the threads. Plus, when we take this off, it also makes it easier to put better sway bar end links on the car. We would take the bolt out. We discard the factory bolt because our bolts are stronger and longer. We then use a stainless steel bottle brush attachment for a cordless drill. We saturate it in brake cleaner and we literally ream the hole in and out with the stainless steel brush with the brake cleaner. And then we fill it up, dump it, ream it, fill it up, dump it, ream it until the rod is clean enough that you can run a white paper towel up in there like you're plugging a bloody nose and pull the thing out and it's clean. Once it's clean, you know that the threads in there are ready to receive compound and it'll actually bond to the existing threads. But before I would put that together, I would take your new bolts and I would go ahead and screw your new bolts all the way in to your clean and ready to go radius rod and make sure that you don't feel any hard spots or significant resistance. Go ahead and maybe measure the depth of the hole with a pencil or a pen and then compare that to how much thread you get up in there when you put the bolts into place. And then once the bolt is in there, give it some of this kind of action to see how much tolerance is in the thread system of the aluminum rod, and are you really comfortable with that amount of tolerance? Because you shouldn't have very much off-axis play at all.
If you have any off-axis play or any lateral play, that would be a cause to
In and
reject
out
the
play or play this way, the rod needs to be replaced.
rod. Okay,
What other questions have we got?
that is what we had in the chat.
Okay.
Jerry, if you would like, I see your hand up there. This is Jerry Hadley.
Hey, Jerry. Jerry's a local guy. We haven't met yet, but we'll see you soon.
Jerry, if you if you have a question, looks like you may have taken his hand down.
Oh, okay.
Okay. If there's anyone that does have a question, feel free to raise your hand or drop it in the chat. We'll make an attempt to unmute you and you can ask a question. Did we answer everybody's questions? I think we got most of them out of the chat.
Yeah. So that's another thing. We did get a lot of questions from the 115 people or so that are registered for this. It's impossible in an hour to an hour and 15 minutes to address all of those. I will go back and review some of those. I have phone numbers for a lot of you. When I have a spare moment, I'll do my best to either shoot you an email or text you or invite you to call, and we can try to address some of those concerns. Our biggest concern today was let's get radius rods talked about again, because if you're greasy, you need to get glued. If you're glued too tight, you need to get taken apart and put back together with judicious torque so that you don't have a sudden failure of that bolt. That bolt is not going to break at a convenient time. It's going to break when you're in the middle of a turn or you're on a bumpy road or something that's super washboardy up and down. And once this wheel is no longer, once this bolt is broken and this control arm is able to move around quite a bit, you're in a greater risk situation than if the bolt was just loose. And we have one owner, what's his name? Mr. Woodard out there has got a 6,000 mile 24 model that he is a daily driver of. And he called me a couple of weeks ago and just said, I nearly died on the highway. He had to throw the brakes on real quick for a situation and the car darted and he didn't understand why. And he called me from home. I invited him to go out and look at the sides of his machine. Sure enough, the bolt was broken on his driver's side. So most of the people that have suffered a break suffered it before 1,000 miles. One person at 2,500 and one person at 6,000 that we know of. But we're above 20 instances of this now. And I don't know what percentage that represents of the number of vehicles that were factory serviced for the greasy bolt problem before they got distributed. But you need to be mindful about it and do something about it so that you can drive without that dark cloud over your head.
Okay, super cool. So if I don't see any other questions up, let us know if this was useful to you. If we're hitting on the right topics, we want to make this the best we can for you as drivers and as owners. We see these vehicles day in, day out, every day, and we're so intent on serving this audience and doing our best to make you guys and gals, I shouldn't discriminate at all. The drivers of these vehicles have just a great experience out there on the road.
Now, Steve, last month we spent, 15 minutes hanging out afterwards, taking additional questions and or addressing a few additional small things. I'm still willing to do that if we have the room for that length of time to help make up for some of our technical support issues here and our
we'll do that
repositioning.
for sure.
Can we do that?
Yep, Michael, we see your question and we'll address that. How do we get the steering wheel straight? If you'd like to hang out for that. Anyone else, you're welcome to stay. And those of you that have got to go at the hour, we want to honor that as well. So thanks for joining. We're going to do this again next month. And what are some of the topics? We didn't get to battery, changing out the battery.
Yeah, we didn't get to battery, but I do want to talk just a little bit about alignment real quick. The chassis wall is the chassis wall, but if this bushing on the outboard half of the system has been tightened to 45 foot-pounds, it's shorter than if it was tightened to 25 foot-pounds. That means the position of the position of the lower control arm has been drawn forward. Because the factory TSB doesn't specify that the technician realign the front end afterwards, there's a good chance that many of you are going down the road with toe out. If you have a 23 or 24 model corrected vehicle, you would know that because the inside half of your front tires are going to be wearing faster than the outside half because the car is going down the road at this kind of attitude. It's scooping pavement as it rolls forward, and the tires are trying to drive away from each other. So the tie rod nut right here would get loosened, and then the tie rod itself would get rotated clockwise or counterclockwise, depending on whether you need to bring the back of the tire inward or the back of the tire outward in order to get a true parallel existence of your front wheels. There are kits on Amazon. The phrase for the tool is toe plate. If you will look up alignment toe plates on Amazon, you can get kits starting at $50. It's 2 extruded aluminum cookie sheets, for lack of a better term. They're designed to sit up against the face of your wheels on either side of the car, and they come with 2 identical tape measures. And you drag the tape measure from the lead edge of one to the other and the trailing edge of one to the other, and then you do the math. If you don't have the same exact measurement at the front plate tape measure as you have at the rear plate tape measure, then you need to make equal adjustments on either side of the car to the rotation of the tie rod in order to correct toe in or correct toe out so that you have true zero toe. In other words, we want to have exactly down to the 32nd of an inch if possible. We want to have the same measurement in the front and the rear. Steve, do you have anything to add about alignment?
Yeah, if you're a DIYer, there are some alignment plates. Did you mention
I
this already?
just talked about those.
Alignment plates, and someone asked about drawing a chalk line. No, you don't really need to do that. You just need to make sure that the measurements are, like Troy said, within a 32nd of an inch, which is like a 16th of a turn.
Yeah, it's a tiny little bit of adjustment on the
So
rod.
when you're doing it, actually use the flats on the stop nuts as kind of your reference point, and each one is on a hex bolt is
Right. There's
1/6 of a turn.
Yeah, there's 6 flats around the radius rod,
And we go down to a 12th to get
12th of a
12th
rotation.
of a rotation
Yeah.
to get that done.
And
So
then that's not even enough.
Right.
Then if you are really into precision driving and you can really feel it, you can get out on the highway, get going 60 or 70 miles an hour and just give the wheel just a tiny little bit of movement. And if you move the wheel a tiny little bit and the car doesn't move, you probably still technically have just a tiny little bit of toe out. And if the car kind of feels like it's wandering and you're still having to adjust the steering angle just a little bit to keep it on a straight trajectory, the next time you have a moment, make an adjustment in the direction of toe in, maybe a 12th of a rotation on either side, and that's it. Now, to the gentleman who said his steering wheel is crooked. Your steering wheel is crooked, yes, but once you straighten your wheel, your vehicle is going to go off to one side. It's going to veer, right? So I'll explain this from the back, and I'll think about the process. If I'm driving down the road and my wheel's normally to the right, and I have to turn it to the left in order to get the wheel straight, the car is going to go to the left. Well, if I've already set my alignment at true zero, my toe at true zero, I need to make adjustments on the tie rods that will move both wheels to the right. Because if both wheels are turned to the right, that's the same thing as correcting the steering wheel to the left. You make opposing adjustments to correct wheel centering. You make identical adjustments to either create toe in or toe out. And it helps to have somebody there that you're talking it out with, because it gets confusing. It's a right-hand thread tie rod on the right side of the car. It's a right-hand thread tie rod on the left side of the car. So if you want to make an adjustment in the direction of toe out, you're going to be going clockwise into the tie rod end with the right rod, which is going to have the wrench going from the front of the car to the rear of the car. But when you go to the other side, you're going to be making the same adjustment going from the rear of the car to the front of the car. So don't get confused about which rotation is accomplishing which adjustment. I just talk to myself when I'm doing it, so I don't lose track of what I was trying to do, because you can really get yourself lost if you're not trying to keep your logic straight. Do we have any other questions to address?
One on an intermittent turbo.
Okay, I did see that question. I'll speak to that real quickly. And this is folklore that I think we can believe, and that is General Motors ran out of wiring harnesses before Vanderhall ran out of power plants. So they had created engines and transmissions ready to build Carmels and Venices, but they no longer had General Motors manufactured harnesses to make the vehicle work. So I have a feeling that they were presented with an opportunity to go find a subcontractor that could clone a factory GM harness, but strip out any of the wires or fittings or connectors that weren't being used on a 20 through 22 Vanderhall that just get in the way and result in phone calls to me and dealers and everybody else about, I found this wire that's not plugged into anything. Where does it go? It doesn't go anywhere. And you don't have windshield wipers. You don't have power windows. You don't have electronic trunk release. All of that theoretically is in the factory harness that came from GM. So Vanderhall went to Mexico where labor and products are more cost effective. And they invited a Mexican harness builder to reproduce that harness. And as it turns out, a lot of the fittings, a lot of the connectors weren't terminated well. And when the fitting or connector isn't terminated well, either you don't have a good male-female engagement because the male and the female are literally bumping into each other. And when you put the two halves together, it actually pushes the male back out of the socket. Even though the two pins are technically touching, they're only touching on the tip. Vibration, heat cycles, shock, age, oxidation, all of that contributes to being on the threshold of proper communication to having no communication. So your check engine light is popping on for those of you that are experiencing this because it has seen an intermittent connection situation 3 drive cycles in a row. It doesn't throw a flag until it sees that problem repeatedly. The turbo problem that you're having is very likely to be related to the 2 wires that run down the right side of the vehicle and connect to the blow-off valve solenoid. We have seen termination issues right there at that connector. I believe we've seen intermediate connections because harnesses don't just go from the electronic control unit straight to the device. They may actually have 1 or 2 other places where there's a male-female intersection of multiple wires plugging into each other. So that means you have 3 sections of wire with 2 terminations each. You've got 6 places where a poor termination on 1 wire could cause you a problem.
Including the fuse box as well. If it may pass through a fuse box, so we've seen them there as well.
The fuse box stabs down into female harness ends that are held there just waiting to receive all of the pins stabbing down into it. And we've actually pulled those out before and found that there was a misalignment between the harness female and the male coming down out of the fuse box part.
So Bill, that's a good point. I'm watching this, that there is no check engine light. What I would suggest is the connection that Troy's talking about, that 2-wire pin. I have seen at least one machine where that actually is in place, but it wasn't actually inserted all the way, or was it locked? So sometimes just checking the connection itself to make sure that it's seated and locked, or even if it is seated and locked, back it up, take it off and just recycle it. Look at the pins inside.
Yeah, I was going to say, you could have 2 wires coming into a fitting and one of those wires has a bend in it.
We have that very problem with a customer who did not have any power steering. And it was one of the large bayonet connectors that are like a 1/4 inch across, pass a lot of amperage. And he had an intermittent power steering failure like you're describing with the turbo. And we actually got a pair of pliers on it and reseated that pin, that specific blade, and that took care of the problem.
Yeah, the plastic molded multi-channel plug fittings that the wires slide up into, they're supposed to have a little anti-back out molding tab in them so that when the metal fitting pushes up in there, it has a little, almost the same way that porcupine quills will go in, but they won't come back out. That's the way these terminals are designed to work when they slide into the plastic housing. But if the plastic housing was made with less than precision tolerances, those pins can just push right back out instead of staying locked in where they belong. So if they meet with resistance when the male and female are coming together, you may just have a wire back out and the technician or assembly worker who put it together just didn't notice.
So Bill, just to wrap up with this one question, I think your question is, do I need to pull off the side panels? To access the blow-off valve that we're talking about, you need to pull off the outer hood if yours is a Carmel, If it's a Venice, then you just need to take off the hood itself, and you can access it. It's kind of behind the intake shroud, which you can just remove with a couple of 7 millimeter bolts, so that you get that the elbow that connects the turbo and the air filter slightly out of the way. Or you can just look underneath there and see if that 2-pin connector, it sits vertically with the red safety towards you as you face the passenger side of the car.
Yeah, for those of you that have done Bad News Racing performance tune and you've added the high performance recirculation valve or the S-line recirculation valve to the side of the turbo, the rubber molded intake elbow, we just undo the clamps on that and kind of swing it out of the way so we can get down into the side of the turbo where that valve is, and that's where those 2 wire connections are.
Great questions. There was another one that I wanted to answer real quick for Michael. Thanks for the question, Michael. How do I know if I have a Mexican wire harness? There's a couple of ways, and it took me quite a while to figure it out. So I'm going to share with you the easiest way that I've known. It doesn't work every single time, but the easiest way is to open the inner hood and look for a 6-inch long tab that says "Made in Mexico" as the large wiring harness.
Yeah.
It's the largest bundle that comes out right, pretty much right in line with the steering wheel towards the front of the car.
The age of the vehicle is the key factor.
Yeah,
If it's a late 22, all the way up through 24, it has the harness that we built in Mexico.
we have seen some though that have been marked 21 that have the Mexico harness
Really?
on it. Yep.
Oh goodness. Okay.
Another good way to check is the braiding as it exits. I'm going to call it the inner cowl. The cowl. If you've got the outer hood off.
Yeah, that braided loom that wraps all the wires.
If it's the braided loom and it is wrapped with that really cheap electrical tape that kind of loses its stick.
Mm-hmm.
That's another indication that you've got a Mexican wiring harness.
If
the
you were
fail-safe
going,
way is if you really want to tear into your car,
yeah,
you pull off the the outer hood. What we're calling the outer hood is really the fender hoods.
it's just the hood that doesn't move unless you remove it. Yeah.
And then take off your windshield, and then once you're down that far, you can lift off the inner cowl cover, which is a black textured vinyl cover behind the dash. And if that thing is jam-packed with wires, we
need a graphic next time. We'll try to have a graphic.
If it's actually got a wire loom that looks like it's in a black box that's shaped like an arch that goes over the body control manual, that is the original GM harness. If it doesn't have that and it looks like the space is only half full as opposed to 3/4 to 7/8 full,
Yeah.
then you've got the Mexican harness.
The GM harness is a lot bigger bowl of spaghetti under that wiring cowl than the Mexican harness is. What else have we got?
Well, we're
We're kind of
15
at
minutes into this.
Yeah.
You guys are loving this. We're loving it as well. Let's take one more of us. This is R.A. Cater. So he or she asks, I have a stock 21 Carmel, and I'm curious how often I should hear the turbo flow off valve. What is a normal boost pounds? I guess what he's asking is, what does it indicate?
Yeah, I think Devin has a better understanding of the maximum boost range on the gauges. He's looking at me with big eyes. So I want to say that you see boosts up to 30 PSI when you have a Bad News Racing performance tune, and it's going to be closer to 15 to 20
I concur
if
on
you're
that.
factory.
Yeah.
And so the noise that you're hearing, that's releasing excess boost pressure, usually at the top of an RPM cycle. So, or you got into the throttle to give it the beans, and then you let off the gas. The turbo continued spinning and was still accelerating at the time you let off the gas pedal. And the ECU signaled immediately, hey, we don't need all this pressure, just let it go. So that's when you should hear it. And When you're driving along moderately, just kind of holding a steady pedal, but at a slower speed. Let's say you're trying to crawl through a school zone or something, you may actually hear a whole lot of pressure and release, pressure and release, pressure and release, because you're kind of just dancing on using the turbo the slightest little bit. And it's just not designed for, it's not tuned for lower gear, slow speed maintenance. It's really designed for accelerating through the gears. That's the way the car's tuned.
I hope you enjoy it. Actually, that's one of my favorite sounds.
Yeah,
Out of
yeah.
the vehicle.
We've had lots of people send us videos and say, it makes this crazy noise. Is that normal? Yeah, that's supposed to be part of the fun is, hey, I got a turbo, and everybody around you knows it because they can hear the.
Well, thank you, everyone. This has been a pleasure. Thank you for bearing with us during our multiple partial outages. Really appreciate your patience. And we'll see you next time on the VanderSpa Performance webinar.
Thanks, guys. Y'all have a good night.